Howdy folks. Today we are going to take a look at part 2 of how to break down a project and turn it into code. So in the first part we looked at breaking the project and taking its initial data and what we were told to do and breaking it down into tasks. Today we're going to look at how to turn those tasks into pseudocode. Let's get started. So, to refresh your memory, the project that we were working on is essentially kind of a hangman type game. So we have a word for the player, and we display blanks for that word and let the user type in letters. And as they type in letters, if they pick a letter correctly, we show that letter, pop it up. Otherwise, I guess there's no penalty for losing, and there's also not a little drawing of the hangman, but otherwise it's pretty similar. So I've got my tasks folder here. These are the tasks that we came up with in part 1. I've also got a script and an index. Both these are blank. So I'm not going to look at these for now. Let's look at our tasks. So first task, as a user I want to try to guess a word by filling in a number of blanks that match the number of letters in that word. So there's a couple things here. We need to have a word for the user to guess, some way of tracking guesses, etc., etc. I'm actually just going to copy these, and here's what you can do. Copy these, and then I'm going to use a replace to replace all the asterisks with comments. Now, this actually becomes comments that we can use. Actually, I kind of want those indented. And this provides a basis of the program, and also it's good to have comments, so we're just going to leave those in there. We need to have a word for the user to guess, okay. So note, I'm not going to write actual JavaScript here. I'm going to write some pseudocode. So I'm going to say define word equals JavaScript. See, I could just put const, I suppose, as well. That'd be fine. But then it wouldn't really be pseudocode. So I guess the thing about pseudocode is it's kind of a spectrum. You can have pseudocode that's very much not at all JavaScript or any real language. It's just something that exists and kind of is a structure of how you want to put your stuff, because that's what it's really for. It's meant to structure without being confused about the language specifics, right? Maybe you don't remember how to do a variable, maybe you don't remember how to do a function. That's okay. This is meant to give you the idea that you don't need to know the language in order to write the pseudocode. Then there's pseudocode that's much closer to the actual real language, kind of like this. So I've got, this is not real JavaScript, right? But define word, I could say as JavaScript. We need some way of tracking users' guesses. Define guesses as empty. Oops. And actually, I'm going to change this. I'm just going to change this to a text file, because otherwise I'm going to get those errors. We need a way to track the number of blanks, which should be equal to the word letter count. Well, we kind of don't need this because we already have the word, and so we can just get the blanks as the count of the word, right? We need a way to describe and display the number of blanks, okay? We need a container on the web page that will hold elements for the blank letters. Well, let's go in here, because that's a web thing, right? That's HTML. So I'm going to go in here, create a page, and put a comment here. Okay, do ID equals letter container. Simple. This is not really pseudocode, but it's easy enough to put in there so that when I do actually start writing my real JavaScript, it's already there. And you notice I've again got that comment. So I'm actually going to remove that comment from here. We need a function that populates the above container. Okay, well, function populate. Okay, container with blanks. So let's look a little bit at that. Okay, how do we populate the container with blanks? So this brings us to a really, really valuable tool that we can use in breaking down anything into an algorithm. If I was doing this by hand without using an algorithm, without the algorithm at all, and I was just telling step-by-step instructions of how I would do it. So let's say I had a container on the web page and I knew I had to put some blanks in it. Well, probably I'd create a new element, I'd give it a dash, right? And then I would add that element to the parent element. And then I would do that for how many times I have letters in the word. And so you could see, like you can imagine if I'm writing down a piece of paper and just writing a bunch of dashes, I'm going to count how many words there are. I'm going to make a space for each dash and I'm going to write it down. So we're going to do something like that here. We're going to say, okay, create a new element. Set that element, oops, text to dash. Add that element to the container. So you can start to see the power of the pseudocode here. This is an algorithm now, right? And I actually want to say, you know, this only do it once, but let's get to that in a minute. This is an algorithm. Creating a new element, setting text, add an element to container. That could be very different depending on how you're doing it. Are you building this in React? Are you building this in jQuery? Are you building this in raw JavaScript? Each way is going to have a different way of doing things, but you're dealing with that later. You're not worried about that right now. Right now, you're just worried about what's the algorithm. And so see, create a new element, I know what that means. And at some point, if I need to, I can look up how to do that. So I do actually want to loop this. I can say for character in Word. And then just indent these to kind of indicate they're in that loop. I'm done. Do I know how to do that? Maybe. In JavaScript there's a way to do it. Maybe I'm doing some other language, but it doesn't matter at the moment. Right now I'm just writing the algorithm. We need a way to get keyboard input from the player. Okay. When the user types a key, we need to check it against the word and update the blank. So first of all, let's do this. Function. Okay, handle keyboard input. Check it against the word and update the blanks. What does that mean? Okay, so we've got these algorithm pieces in here. When the user enters a key, determine if it's valid. What does that mean? Well, we want to make sure that the user typed a valid letter. Okay, so check if user type. Well, let's just do this. We'll do it a little better. If key is a valid letter. Now here's a question that first comes to. So if key is a valid letter, we want to continue on with the function. We kind of want, if key is not a valid letter, we want to exit the function, right? So I'm going to change this a little bit. If key is not a valid letter, return. This is there's a common pattern like this. Basically, you can do it two ways. You can say if condition statements in here, or you can say if not condition, return statements out here. The benefit of this one is that if you have a lot of statements, they're not all indented inside the if statement, which can be a little messy and hard to read. Instead, you've got a very clean condition that just exits. If you have if statements or loops that are really, really long, it can make your code messy. So that's kind of why I'm going with the second pattern instead of the first one. They both accomplish the same thing. Okay, check if key input exists in the word. How would we do that? Okay, so what we would do is, if I'm checking to see if it exists in the word, I'm probably going to look through every character in that word and see if that character is equal to my key. So let's do that. For character in word, if character is key. Alright, what do we got to do if character is key? If the key input does exist in the word, update the blanks, replacing blanks with the appropriate letter at the appropriate place. Okay. So we actually do need to track the blanks then, because we're actually updating blanks at this point, not this. So let's do this. Instead, so now what I'm doing, before in populate container, we just went through the word and put a bunch of blanks. But now I actually need to be able to update these, which means I want to be able to track them individually. So I'm going to say define blanks as string of length, same to word, full of dashes. This might be 3 or 4 lines of JavaScript. It's okay. I can just define it as pseudocode here, as long as I know what this means. Okay, in this case now, we're going to actually go for character in blanks, set elements text to character. What does that mean? Now I'm using the blanks to figure out where to get my stuff from. Okay, So now down here, we're going to say, okay, set character of blanks at the same position. Well, you know what? Let's see. For character, let's just do this. At index in Word. Set character of blanks at index to character. I could say set value to make that a little more clear. So now I'm going to say, okay, handle keyboard input. If key is not valid, return. For all characters in the word, if the character is the key, set the value of the blank at that index to be that character. Cool. And then maybe at the end of this, I would say call populate container with blanks to redo the data and show the new data on the page. And then maybe about this, I'm going to say register handle keyboard input as a key listener with the document. I don't need to know how to do that right now. I just need to know that's something I need to do. Okay, so now this is still not JavaScript, but it is pseudocode. And you could see how this could turn into JavaScript. You may have to look up stuff to figure out what to do, but this is the next stage. So let's see what's next. As a user, I want the game to be timed. So let's grab this. Okay. Pop that in here. Okay, seconds left. Define seconds as 60. Okay. Every second the game is active, this variable decreases by 1. Well, how do we do that? We need to set a timeout. So I'm going to say that run every second, decrease seconds by 1. Again, I'm just kind of using some very simple syntax here to say, oh, you know, every second I want to do this. You know that's probably going to be a timeout and how you set that timeout, but we're not worried about implementation details right now. We're just figuring out how the algorithm works. Variable is displayed to the user. Ah, well, that's something that actually needs to be in here, right? So I'm going to grab this and I'm going to put another comment in here. Oops. And I'm going to change this to timer is displayed to the user because on this page we don't know what this stands for. ID equals timer holder. Cool. Again, I don't need to do this right now, but I'm just leaving it there so that, and in fact, I could probably go back here and say add that element to the container like that, just so it's clear from the pseudocode what container I actually created for that. Okay. This variable is displayed to the user and user can see when it changes. So let's call function update score. Okay. Set value of, oops, this is going to be the score container to seconds. Pretty simple, right? And then when I run every second, I want to call update score. Because now every second it's going to decrease and it's going to update the score. Again, don't need to know how to do this right now. I'm just building placeholders for it so that I can do it later. Okay, as a user, I want to win the game, and I guessed all the letters in the word. Let's grab this. Okay, pop that in here. When the user has filled in all the blanks the game should end, we need to stop the timer. We need to display a victory message. So this actually kind of belongs up here in handle keyboard input, right? But maybe we want to keep handle keyboard input simpler. So let's make a new function here, okay? Let's call it function check game end, okay? And in here, stop the timer, so let's just put stop the above timer run every second. And then we need to display a victory message. We could make a new place for that. We could just put that in the timer, in the score container too. Did I call it score container? I called it timer holder, not score container. Alright, so let's just add a new thing in here, okay? Equals message holder. So then I'm going to say, okay, oops, want that back. And I'll say, okay, display a victory message. So how do we display a victory message? Well, we don't even need to know what the message is. Display victory message to message container, or was it message holder? It was message holder. Again, I don't need to know what that message is right now. I just need to know this is the place I'm going to do it. Now, I also want to check the game ends when the user's filled in all the blanks. So actually, I do need to check that criteria, don't I? So let's do this. How do we know if the user's filled in all the blanks? Well, there's a couple ways we could do that. One, we could go through everything on blanks, every blank, and see if they've been filled in. The other thing we could do is we could just compare blanks and our word are the same, because if they're the same, all the blanks have been filled in. So either one of those would work just fine. How do you figure that out? Well, write down your word and fill in the blanks on the table and figure out when do you know that they're done. When you've run out of blanks. So you could check that. You could just say, let me loop through blanks and see if anything is blank. An actual dash. That's completely fine. That would work. It's just checking the strings is a little bit easier. So I'm going to say if blanks is same as word. And we'll just indent these to indicate they're in there. Cool. And up here, after I populate the container, I want to actually call check game end. I know I need to do this just because I need to verify and handle the users doing this every time they type a character, because the game might have ended. Alright, so now, as a user, I want to lose the game. Okay, let's do this. Time runs out because I've guessed all the letters. So we'll pop this down here. When timer runs out, the game should end. Instead of victory message, display defeat. So I'm going to make a new function. Handle timer out. And then I'm just going to display loss message to message holder. And actually, we probably want to stop the timer at this point too, right? Stop the timer. So I don't want to handle the timer out unless if seconds is 0. Then we do that. So now every time we decrease the seconds, we also want to call handle timer out, because that's kind of the condition in which that's running, right? So these are not entirely connected until you do that, and so it's important to kind of remember that that's there. But the important thing is there's not actually a tremendous amount of code on the screen yet. There's not a bunch of JavaScript. This is all just words in roughly English still. So if you want to change stuff here, it's actually very quick, because you can use whatever syntax or whatever words you want to describe it. Right? So I could use equals here. I could use is. If I want it greater than, if I want to say less than equal, is 0 or less, I could put that in there. It's up to you how you decide this, and that's what makes pseudocode powerful. Alright, as user I want to see my total wins and losses on the screen. Well, let's grab this. Okay, we'll come down here and do my replace again. Okay, we need to define two variables. Okay, define wins as 0, define losses as 0. When the game ends, we need to increment the wins variable in case of victory and the loss variable in case of defeat. Well, that almost kind of seems like I want a function for game end. Well, game end, and this takes in a parameter 1. Okay, if 1, increment wins. Else, increment losses. Okay, after incrementing, we need to persist these variables to local storage. So I'm just going to say send wins to local storage. Send losses to local storage. Again, I don't have to know how to do that right now. I just know that's what I need to do. Okay, when the page loads, we need to fetch these values from local storage and put them into the win and loss variables. Okay, so now I'm going to say, right now, page loads, it goes through all this. So I'm going to say, okay, get wins from local storage, get losses from local storage. When the game ends, show the win and loss counts in the final message. So actually, what that's tells me is I kind of want to take this loss message or this victory message and pull it down here because the win and loss count needs to be there. Totally fine. I can take this and I can just put that in here. Display victory message containing wins and losses to message holder. Go here. Where's the other one? This is when the timer runs out. Yep, there it is. Display loss message. Otherwise, in here, display loss message containing losses. And you can see it's very easy to do this because it's just pseudocode. I don't care if this code actually works because the only thing that matters is that I can read it and I know what it means. Now, handle game end. We want to call those and check game in and handle timer out. So, call handle game end true. Call handle game end false. Again, I'm mixing stuff that could be valid JavaScript, but then isn't entirely. And keeping these functions small is really good because it means that when something goes wrong, it's a little bit easier to figure out where it went wrong. I could have this all in one massive thing. I could pull everything in here into handle keyboard input, but it'd be so big. And also just the way that all my tasks have come out has made it kind of nice. So this I'm actually going to pull up to here and just say, okay, you know, when game ends, show in final message because we're handling that here. Alright, I want to start the game by clicking on the button. Okay. So what that tells me, let's do our replace here. What that tells me is I don't want my timer to start off immediately, right? Create a button on the main page. I'm going to get rid of that. So create a variable, track if the game is started or not. Define game started as false. If the game is not started, the timer does not decrement. Okay, so this actually, now we do kind of have to move this because this does belong inside the second. So I'm going to use the same pattern as before. If game not started, return. Same idea here. If the game is started, the user's keyboard input, or is not started, the keyboard input is ignored. So come down here and we'll say OK. If game not started, return. Alright, last one. When start game button is clicked, game starts. Okay. You know, honestly, this itself is almost just pseudocode already. When start button clicked, set game started to true. This is probably going to be a pulling the element, adding an event listener, etc. Don't need to worry about it. It's just pseudocode right now. Okay. Final tasks. Before game starts, there's no chosen word. We have a list of predefined words. When the game starts, we choose word at random. Well, let's take a look at this. Okay. This one looks like it probably belongs at the top where the word is. So I'm just going to set this as null. No chosen word. We have a list of potential words. Define word list as a list of words. I don't need to come up with a bunch of words right now. I'm just trying to figure out the structure. Again, leave that cognitive load till later. When the game starts, okay, we choose a word at random from the list and assign that as our chosen word. So actually, I'm going to do this. I'm going to make this kind of a thing here and pull that in. I've just made it look kind of like a function, right? Which I can totally do because pseudocode. Pick random word from word list. Set that word to word. Alright. And actually, now that I've set the word, I probably want to call populate container with blanks. Right? Because as soon as I pick the word, I want to show that thing there. And so you can see, even though I've gone through the tasks here one by one, I've thought of little things as they come up, like, oh, I should probably do this. Follow that. Totally fine. You've got all your stuff written down, right? You've got your comments, and if you go to the bottom, you can see what comments you haven't handled yet. So if you need to do something else in your pseudocode, go ahead and do it. And that's that. So we've gone from roughly, what is this? 50-something lines of tasks. To now we've got about 108 lines of pseudocode. One important thing though, look at how many beautiful comments we have in here. There's so many nice comments. I'm going to actually change this back to JavaScript right now just so you can see. God, there's so many great comments in here. And so now, if I'm confused about what anything in my code is doing, I can just look at the comments, because those comments is what are generated the pseudocode. At this point now, I can go through here and start turning the pseudocode into actual JavaScript. There may be errors that pop up. There may be other things that I learned that I have to do, but for now, this is the algorithm. This is the program. Almost everything in here, if I run this, my program will work. Hopefully. If I was to give this to a person and tell them to execute my program on a piece of paper, they could probably follow along with my pseudocode and figure out how to do that. So, basically, this is how you go from tasks to pseudocode. Remember, pseudocode is not meant to be real code. It's meant to structure like real code. Because that's kind of the hard part of figuring out what you're building, right? Is figuring out the structure and where things are going to go. So we did that here. We reduce our cognitive load. If you don't know how to do something, just write down that you're going to do it there. And that's good enough. Like, stop the above timer. How do we do that? Well, you could probably use clear interval, but if you don't remember clear interval, you just know you need to stop the timer. Just write stop the timer and then look it up later. Anyway, I hope this is helpful. When we get to part 3, we will actually turn this from pseudocode into JavaScript. Take care, folks, and I'll see you next time.